Hello my friend, welcome back. This is the second part of the video from a series of videos that I'm going to provide for you regarding using PLAXIS 3D program for building three-dimensional models of tunnels, in which I'm going to share with you some tips and tricks in building and analyzing tunnel models, and maybe I add some other features of the program within a model, like a deep foundation or interaction between a tunnel and deep foundation, and also interaction between a tunnel and another tunnel that is already being under excavation. So if you haven't watched the first video, I highly recommend you to go ahead and watch it, and let's go ahead and get started this new video. All right, let's go back to the model that I just started in the last video. So I just defined the extent of the model, and this is the extent of the model. So I'm gonna go ahead and define the stratification of subsoil layers. So in order to do that, I need to define boreholes. Let's see, create boreholes. So I can import soil parameter or characteristics of the soil layers from a previous file. But if I just want to start from scratch, so I can go ahead and just click on it, define a location for the borehole. If you remember, I already defined the borehole at this point 000. Based on the geotechnical investigation report, I realized that there is a special stratification area in the location that the tunnel is going to be excavated. So I need to define at least 3 boreholes in order to simulate the three-dimensional stratification. So let's go ahead and define the other borehole at this corner, and as we can see, this is the coordinate of that borehole, and I'm gonna define another borehole at this corner like this. Okay, and it's up to you to just move these boreholes from this corner to within this area. Let's just do it with this borehole. For example, you wanted to move it a little bit inside the model, so let's change it to -20, and this one to 50. Okay, right? Okay, so still there is no depth, and I can go ahead and define the depths of the model, but by defining the depths in the borehole. You can see the borehole within this model explorer, because we haven't defined the soils. There is no way to see the boreholes, so I need to go ahead and click on one of these borehole, for example this one. Okay, so assume we have 3 subsurface layers. Okay, so I'm gonna go ahead and define the first layer as top 0, bottom -5, -4, and this layer underlain by another layer -9, and this layer underlain by another layer that's 20, and that's it. Actually, let's do something -12, and this change to -25 or 30. That's better. Okay, so you can see the sign of the groundwater level, which is located at the ground surface. So if I click OK, you see part of the model is already generated. So I need to go ahead and define the rest of the borehole, because I have defined 3 boreholes. These things happen if you, let me show you something. If you don't define this borehole, let me delete it, and this one delete it. See, by one borehole the program assumes that all of the layers are horizontal and define this the 3D model for you. Okay, so before defining the rest of the borehole, I'm going to go ahead and specify the soil layers. So this is my borehole. I just double click on it. If you come to this model explorer, you can see that the 3 layers that I have defined appear here. Okay, there are multiple ways to define the characteristics of soil layers and material models. One way is to go ahead and double click on the borehole, and here you can define the material. Okay, the other way is to go ahead and define your material in the material sets. So once you define the material sets, you can assign it to a specific layer within the borehole. I'm going to define a new set of material. Just delete everything here and new. Okay. Actually, I have some information from these layers from one of my past models. My purpose for this video, for this specific video, is to just show you the procedure to build your model, the initial steps that you need to take to build the model, and in the future we can deal with specific soil models like soil hardening, soil softening, or hook burn for such cases that we're supposed to excavate through bedrock. So this is the table of parameter for the soil layers. So let's go ahead and do the same as it explained here: upper sand, middle clay layer, and bottom stiff sand. Okay, so I'm gonna go ahead and define upper sand layer. Okay, more column. You have a lot of option for material model. As I told you, I leave complex models for future, and right now I'm gonna go ahead and select a simple model and assume that the model is in drained condition mode. Okay, and let's select like this parameter. Actually, we have multiple tabs in material model. The general is the general information about the soil layer, but if you want to specify the parameter of the soil model, you need to go to the parameter tab and specify the parameters. Okay, so E is 1.3 E4, and let's go back 1.3 E4, this one. And so this is a coarse grained soil layer, and it's in the drained condition, so we need to specify a very low value for cohesion. Let's take it as 1. I don't want to put 0 in order to avoid any computation error. And angle of internal friction is 31. So the rest of the parameter is like this, and leave it like this. We don't have any dynamic analysis or any specific information about variation of the soil parameter with depths. So leave it like this. I don't want to do any seepage analysis, but in case that you have a seepage analysis as part of your main analysis, so you can go ahead and define the coefficient of water conductivity by employing this chart. It's very simple. Actually, just let me explain it very quickly. For example, you can define different conditions for your soil layer. You can assign a different guideline for defining the water conductivity of the soil layer, and based on the standard, this parameter is going to be set. So for example, let's use USDA, United States Department of Agriculture, and you can assign this model or approximate one, depending on depending on how much complexity you would like to assign in your model. Okay, and by clicking on each part, you can specify the type of the material, and based on that you can assign the water conductivity based on the type of the material and grain size distribution of the material as per this chart. Okay, the combination of guideline, model, type of soil can lead you to water conductivity parameter, and you can assign it within a seepage analysis during your main analysis. Okay, just forget about this, and I don't have any seepage analysis in this simple model, and leave it like this. Let's go to the interface. We have already defined the general properties, which are unsaturated and saturated unit weight of the soil layer, and parameters, which are stiffness and strength parameters. And now I'm going to go ahead and define the interface parameter. If you don't have any specific structure that you're going to define solid structure interaction, you can leave it like this, or you can go ahead and define the interface. So again, we have multiple options for this section. We can define interface parameter based on the standard, or based on the KN, KS, which are the normal stiffness and shear stiffness. Okay, and let's make it simple like this. An initial tab for generating the in-situ stress within the model. Again, multiple option, manual and automatic. If you go ahead and select manual, you can change the coefficient of lateral earth pressure. You can calculate it based on the Rankine or Coulomb methods. Again, I am go ahead and make it simple. Automatically it will be calculated. So let's go back and see everything is okay. I may need to define some embedded piles within the soil profile. Maybe in the future I need to go back and modify this strength parameter and define a reduction value. But right now I'm gonna keep it as a rigid. Okay, so let's push OK. This is your upper sand layer. You can change the color of this layer, something like this, and the first layer is defined this way.